words are easy in Western languages. If you happen to be dealing with a non-Western language, then sometimes things get really, really hairy. So Asian text, for example, doesn't have explicit markers for ends of words. What it really is a contiguous stream of characters. And I don't actually know any Chinese, but what I've been told is the way that native speakers read Chinese is they look at the sequence and they don't do it word by word. There aren't words there. They actually extract meaning from subsequences. Right? So now that's great for them, and it's not so good for Python and for us. So how do we get around that problem? We have all this methodology built around words. So what do you do for a language that doesn't have natural word boundaries? Well, you could try to learn segmentation, right? So this could be one way in which a human speaker would segment that stream of text. So that's a drought, that's China, and so on. That's a non-trivial problem. Now, for big languages like Chinese, there are segmenters that will take a string of text and segment it. But if you're dealing with a slightly less well-resourced language, a language that perhaps has fewer speakers and fewer efforts devoted to it, then you're not going to find a segmenter. That's so you can't really do that. So what can you do? Turns out that you can do a fairly simple and on the surface completely brain-dead thing that works surprisingly well. So what you do is you take this sequence of characters, and what I'm going to do is I'm just going to take bigrams, character bigrams. I'm going to take two adjacent characters and pretend that that's a word. But I'm not just going to take bigrams, I'm going to take half overlapping bigrams, right? Why do I do that? The reason I do that is because, right, so the first bigram is actually good, that corresponds to a word, but the second bigram, I was supposed to use a single character, and I'm taking that character and merging it with this guy, and what I'm doing now is I'm ruining China. Right? See what I've done? I've just split China in two. The first half of China, this character, goes into my bigram number 2, and the second half of China goes into bigram number 3. That's bad. Now I don't have China anymore. But if I do that, if I use half overlapping bigrams, so basically characters 1 and 2, 2 and 3, 3 and 4, 4 and 5, now I can preserve China. So that's 1 and 2, 2 and 3, 3 and 4. And there's China, right? So we haven't lost it, which is good, right? Now, in the process of doing that, again, I'm introducing some really, really nonsensical things. Right? That's a word, but these are certainly not words. They have no meaning. They're these artificial, weird constructs that are not words. And that is not a problem. That will actually help us because I'm going to use the same process on the documents and on the queries. So these artificial, nonsensical, non-word constructs, they will be created from both the document and from the query. And if there's some overlap there, they will actually help me match the right stuff. And I guess in practice, again, you always mix it over different n, where n is the size of a bigram. So you don't just take bigrams, you take unigrams, single Chinese characters, bigrams, trigrams, and for Chinese that's enough. You don't need to go beyond the trigram. So the really surprising thing is you do this, you end up with a tokenization that for retrieval purposes works better than this. So it's actually better to do that. You get more effective results than if you went through the pain of creating a single question. How do you know how large an M2B has to be for a particular language? So, I mean, the best thing to do is if you have anyone who speaks the language, twist their arm and get them to tell you, at which point it becomes just total gibberish. If you don't have anyone who speaks the language, or speaks the language and speaks your language, then you try to estimate how rich is the character set for the language, right? So Chinese, actually, an even simpler thing. If you have any example of tokenized text, that should give you an idea for what the average word length should be. And if you never see words bigger than 3 characters, then you don't need to do that. Aside from that, you try to estimate basically how many different characters they have. So if they have 30 characters, you may need to have longer n-grams. If they have thousands of characters, you're probably looking at bigrams.